code problem, implement try. So try is actually a prefix tree data structure, and the advantage of using a try is that all the lookup operations take place in O of n time, where n is the length of the string that we are trying to look up. Another big advantage is the amount of memory it uses. So compared to every other data structure, whether it's array or a hash set, so the try data structure is the best one in terms of memory usage. So for this problem, I was asked this problem during my Google phone interview, I should say, where essentially we start with, okay, you're given a list of numbers. What's the best way to look up the numbers? So mostly the interviewer is looking to see to test your knowledge of data structure and see how comfortable you are talking about it. So I started by saying I could use the array list, and then be like, okay, what if I need quicker lookup? I could be like, okay, then you can store in a hash set. Then he said, okay, you need a data structure where you can look up in a small amount of time, but at the same time, the memory constraints are there. So you need to have use less amount of memory. And the problem he gave me was a list of phone numbers. So that way, the values be limited from 0 to 9. So at that time, I suggested a try data structure. And I think because of this answer, I was asked to come for the actual on-site interview. So this is a very useful data structure to learn about, and if you're trying to impress the interviewer, you should definitely try to bring it up during a conversation. So yeah, the advantage of this data structure is that all lookup operations take place in O of n time. So yeah, actually they've just given us a skeleton code, and they've asked us to implement, insert, search, and starts with. So the way that the try data structure is implemented internally is that essentially there's a try node. Each try node has an array of try nodes inside of it. That array will be of size equal to the characters we are trying to save. So in here they have already given us a constraint that the input will only consist of lowercase English alphabets. So we can start by saying the try will be of size 26 because there are only 26 alphabets that can be saved. Another thing we're going to see is a Boolean value. So the only purpose we have this is to check whether or not the string exists. So I'll try implementing it, and hopefully that'll give you a better understanding. So first thing we do is we check if word.length. So this is a method for essentially given a character, change it to like an index. So since I said the input will only consist of lowercase English letters, by subtracting a, we are just converting it into a value from 0 to 25. So yeah, essentially what I'm doing is given a input, I'll take the first character, and if it's already been initialized, we don't do anything else. At that particular index inside of that try node, we initialize that a new try data structure, and inside of that we input the word after the first character, and we keep doing it until the length of the string is 0. So here I'll just create the if condition. We just here we just say this dot end. So the advantage of this is now we have marked that if you are trying to save the word, this is the end point of that. So yeah, given an input like apple, the way it's going to work is that at index 0, we are going to initialize a try node. Then inside of that try node at index for p, we'll initialize another try. So that way the insertion operation will take place in log of O of n time. And when you're trying to search inside of the string, the way we'll do it is similar to how we did an insert. So So hopefully this makes sense. What you're doing is we're checking at the particular index. If the value inside of the index is null, then obviously the string has not been saved, so we return false. Else, we take the first character off, and the remaining string we pass it as input to that particular try data structure stored at that index, and we keep doing it all the way until the length is 0. So once the length is 0, what you have to check is the boolean flag which we have saved, this dot end, is equal to true. So we just say this, return this dot end. That indicates the string has been saved inside. So starts with is pretty much similar, except that instead of the this dot end, we always return true. So actually I can just copy this. Let me do that. So we check if prefix dot length greater than 0. So and here we just replace it with starts with, and here it's always true. So other than that, I think it's the same as the search method. Actually, we can probably refactor the code. I'm just too lazy to do it right now. So let's try running it. Oh, yes, that's a problem with if you try copying code, you always miss something like this. Okay, the 2 use cases have passed. Let's try running it, submitting it. Okay. So yeah, the time and space complexity. The time complexity, I think, like we already discussed, will always be equal to the length of the string that you're looking at. So O of n, where n is the length of the string to be inserted or searched. As for space complexity, here's the way advantage of using this data structure is that we reuse the space. So it's a case where if the prefix is the same, we won't be creating new data structures every time. What we'll use will only use the existing ones. So I would say the space complexity will be O of n, where n is the number of unique characters in all of the strings, if that makes sense. Because every time we create a new unique string there, we reuse existing values that we have for try, and only the new characters cause us to create, insert or generate new try data structures. So in that way, I think I would say O of n, where n is the number of unique characters in all the strings.